Hello guys, this is Shailesh Gupta and I welcome you all on our YouTube channel Gyan or Vigyan. In the lecture series of Chemical Kinetics, today it is the third part. So guys, if you haven't seen the part 1 and 2, just go through the channel and watch it first and then come to here. In this video lecture, I am going to discuss about the characteristic features of zero order reaction, and at the end of the video, I'll give you some assignment. So without wasting any time, let's get started. Now let's look at guys zero order and the characteristic of zero order reaction. Now isn't it very interesting? A zero order reaction means no matter what concentration of reactant you are going to increase, the rate of reaction will be constant. Does it seems to be practical? Means imagine that A and B are taken together and forming some product, okay, and we are saying that no matter how much amount of A you are increasing, how much amount of B you are increasing, the product formation rate will be independent, it will not be affected. So let us look at this particular thing with the help of certain example, right. So what is the key point associated with this reaction? This reaction is mostly induced on the decomposition of the gases on the metal surface, and at the same time mark this word at higher concentration follows zero order reaction. Few of them is given, number 1, 2, 3 and 4, and you can see the fourth one which is not induced on the metal surface also, it is induced by the light. Here also you can see the situation, right. Now why it is happening at a higher concentration, why not here lower concentration is written, and how that thing which were actually looking to us as impractical is actually practical. Now let us understand with the help of the diagram which I have shown it here, right. Now see, this is the reaction and let us consider this is nothing but a nickel catalyst, and let us understand that this pH3 molecule, when it comes close to the surface, it decomposes here only on these sides, and this small circles which I have made here are the sites where pH3 will settle down. One pH3, another pH3, another pH3, they are going to get settled down. Now guys, you understand, suppose we have a very small concentration of pH3, what will happen? It will occupy few of them only, few of them will decompose. Now what will happen if we will increase the pH3's concentration? Now slowly more pH3 will occupy, so more occupy means on surface more will decompose. Now if I will increase more, then this will also occupy. Now once all are occupied, all the sites are occupied, if I am increasing pH3 more and more and more and more on the above the surface of this catalyst, will it help in decomposition of these gases anywhere? Because all the sites are already occupied. Now no matter what amount you are going to increase, it is going to decompose per second only these which are already settled on the surface. Suppose these sites are 50, then maximum it is going to decompose 50 per second, no matter how many pH3 you are going to take into it. So this is the condition where I was saying that at higher concentration, look at this higher concentration, because at lower concentration when initial sites are filled, if you will increase, more number of site will fill, more decomposition will be there. In that particular case, it will not be zero order. But once all of these are filled, thereafter no matter what concentration you are increasing here, it will not depend on that. So these are a very practical cases which I have written here. Now coming to the various aspect and how to approach the question related to it, right, and it is the most important thing, because from now onwards the theoretical part is over, mostly the numerical part will come, right. So I have given you, consider this zero order reaction which is A forming 2B and the rate constant given K, temperature given T, initial concentration of A is given to be A naught guys, A naught. Now what I am interested? I am interested to ask tell me the concentration of A at time t, tell me the concentration of B at time t, tell me the concentration of the rate expression as a function of time, tell me how much time it is going to take to complete 10% of the reaction, half life, T 90%, all of these. So, let us start how to solve it. Let us start. So, how to do, guys? You first write the rate expression. R is equal to, I told you, dx by dt, which can also be written as minus dA by dt, which can also be written as 1 by 2 dB by dt, which is equal to K into, because it is a 0 order reaction, A to the power 0. Now, just look at this reaction. For this reaction, initially what was the concentration of A? A naught. What is the concentration at time t? At general time t, you know x molecule of A will react. So, how much A will left? A naught minus x. This will be 2x. So, can I say here that A at time t in a function of x will be A naught minus x, B will be 2x. If anyhow I will get the x as a function of time, my thing will be over. So, let us equate this one dx by dt with Ka. So, dx by dt is nothing but K into A to the power 0 means 1, implies dx is equal to K dt. From here, now you need to understand one more important thing, guys. See, whatever the part is there within D, differential part D, here we have t and here we have x, limit is always placed for that variable. So, means at t is equal to 0 means when reaction actually just started, to at time t, what was the value of x when time was 0, what was the value of x. So, obviously at t is equal to 0, reaction is not started means x will be 0. So, it will start from 0, at general time t it will be x. Now, you integrate it, dx will become x, 0 to x is equal to K is a constant which will come out, t 0 to t. So, this will be basically x minus 0 is equal to K, t minus 0. So, what we got? X is equal to K t. Our majority of the question is over. Why? Number 1, solution number 1, A as a function of time is A naught minus x, which is equal to A naught minus K into t. So, I got A t is equal to A naught minus K t. Now, guys, similarly B is equal to 2x, which is nothing but 2 into K t. From here, the next question is find the rate as a function of time. So, rate expression was what? Dx by dt is equal to r, and you have seen that that was not depending on A. So, it will always be constant, rate will always, it is independent of time. Next is also over. Coming to the next one, what was that? That was find the T 10%. So, I will tell you one of the method, rest you guys you calculate by yourself. So, T 10% let us calculate. So, what is the meaning of 10%? First of all, understand. So, my reaction was A is consuming and giving to B, initially it was A naught minus x, x is consumed amount. So, guys, T 10% means time when A consumed to be 10%. Means what I am trying to tell you that this x value is actually 10% of the overall value So, whatever the time that it is going to take, that is known as T10%. In another word, you can say time when 10% of the reaction is complete. Now, so this is nothing but this 10% is nothing but alpha, degree of dissociation, you can relate it with that. So, alpha is given as 10% means 10 divided by 100, and we know how to write alpha. Alpha means degree of dissociation, which means how many moles of A is dissociated divided by initially how many moles I took. So, this will be x upon A naught. So, from here what I got, x is equal to A naught by 10. My part is over. Now, we already know that x is equal to k into t, and guys, I got the value of x, just substitute it, that is A naught by 10 is equal to k into t, T10%, T10%. So, I got T10% is equal to A naught upon 10 k, A naught upon 10 k. Right. Now, can you similarly calculate what will be the value of T half? So, what is the meaning of T half? T half means time required to complete half of the reaction, or in another word, time when alpha becomes half. So, alpha is half means what? X by A naught is becoming half, means x value is what? A naught by 2. In that case, once again you apply the same equation k into. So, if x is becoming A naught by 2, our time is basically T half. So, from here what is the value of T half we got? A naught upon 2k. Now, mind one thing, this T half value is depending on A naught. What was A naught? Initial concentration. So, if somebody says that what will be the graph of T half versus initial concentration? So, you can say that, see this graph directly proportional means linear equation passing through origin. And what will be the slope of this curve? Tan theta will be simply 1 upon 2k, right, because this is very similar to y and this A naught is similar to x. So, if you will equate y is equal to mx, this slope value will be 1 upon 2k. Alright guys, so this is it about zero order reaction. Hope you would have understood the thing. We will see the remaining first order and second order in coming videos. Now, by that time I wanted to give you one assignment, you complete it so that I will check in the second case when I am going to discuss about the first order. And the assignment is, consider that A is going into 2B and this reaction is first order, and what else is given to you? You have given the value of rate constant and initial concentration. Now, in this case what I want the relation of log of A naught upon AT value. What will be the value of this in terms of time? Second thing, I want the value of T half in this case. And third thing, if possible, you calculate the value of alpha, degree of dissociation, as a function of time. So, these three things I am giving you as a homework. So, see you guys in the next video.